Howdy, howdy. This is Mr. Potter. In today's lesson, we're going to continue talking about our numerical variables. More importantly, we're going to talk about how to get numerical variables from the user. So in other words, get data from the person who's typing in stuff into the console. Now, normally we use system.out methods to print stuff out to the user. The system out print line, the system out print, and the system out printf. But system.in doesn't have any methods that are easily accessible to us. What we have to do instead is we have to create a scanner object. And what a scanner object does is it gets a source and gets information from that source. In this case, our source is going to be system.in. So I'm going to start this program by creating a scanner object. So scanner in gets new scanner, and in the parentheses, I'm going to tell it the object to be scanning from. Now, for us in this thing, it's going to be system.in. But I could just as easily replace this with a file, or with a modem connection, an internet connection. There are lots of things that I can connect this to. System.in is just one of those objects that I can connect this to. In order to use scanner, though, I have to put in an import statement, like we saw when we were dealing with grid world. So I'm going to import java.util.scanner, and that's going to allow me to use the scanner class in this program. And then what I can do is I can create objects like string data gets in dot next line, and get that information from the computer. It's going to get the next line and save it as a string. So let me go ahead and run this and show you what happens. So right now it looks like the program's not doing anything, but that cursor is down there and it's waiting for me to type in some stuff. So I can say, hello computer, how are you? And what's happened is it stored that result in the variable called data. So if I go over here and ask it to system.out.println data and run this again and say hello computer, how are you, it'll tell me what that data is. So it's a real nice way to get data into the computer. Unfortunately, we can't really do much with strings other than concatenate them, other than put them together with other strings. And the lesson's supposed to be about numerical data types. So what I want to do is I actually want to, instead of just printing out this data, I want to talk about how to convert this to an integer. So int num gets, and I'm going to take data and convert it to an integer. And the way I do that is by using the integer class and asking it to parse the result to an int. So I'm going to take data, change it to an int, and then store it in int num. So now I can do system.out.println num, and it'll print the number that we're dealing with. So I'm going to run this. It's still asking me for something, but I can type in some number, and it's going to print the result of that number. It's going to print 7,233. The thing you have to be careful with in this situation is that if I were to say, hello, computer, how are you? Then it's going to give me an error. And the error that it ends up giving me is it says number format exception. So in other words, it could not take hello, computer, how are you? And convert it to an integer using int.parse. So there's actually an error in Java's code that it has issues with. So I do have to be careful dealing with next line. Next line is going to give me the entire line of text no matter what it is. And one of the ways that I can kind of get around that is by saying int num gets, and instead of saying integer.parseInt, what I can do is I can say int num gets in dot next int. In other words, directly asking for in what the next integer is. So if I wrote a program here and it's asking for a number, I could type in 76 and it would say, oh, your number must be 76. But if I was to run this program and I said, hi, my number is 76, then it's going to still have problems. Because now it's saying input mismatch exception. It was expecting an integer and it got a string. So you do have to be careful, but there are two different ways that you can do this. One is by parsing to an int, and the other way is by directly converting to an int. And in that same context, I could do the same thing with the double. So double val gets in dot next double. And I could have easily used the double class to get double dot parse double to get this information as well. And system dot out dot println val. So now it's waiting for something. I'm going to type in a number like 36, and it's waiting for a decimal now. And I'm going to do 5.6, and it prints out those results as well. So I have ways of getting information from the keyboard to store these in a variable. So what I could do is I could say up here I could do system.out.print, type the width of a rectangle, and because it's a system out print, the cursor is going to wait here until I type in the number. And this is something that we call prompting. And I could just as easily do system.out.print, type the height of a rectangle, again another prompt, and then what I can do is I can print out num times val and say that is the area of the rectangle. Rectangle. And so if I run this, it's still expecting me to type in an int and a double, but now it's actually giving me a question. Type the width of my rectangle. I think my rectangle is 6 wide and 4.3 high, and so it calculated the area as 25.799999997. Again, the same issue we were talking about last time with the decimal places not being perfect. I mean, for all practical purposes, that's 25.78. So, or 25.8, I mean. So, I have ways of getting input from the user and storing that input in variables to be used in calculations later on. So that's the first part of today's lesson. The other thing that I'd like to talk about is I'd like to talk about some special features of the double class and the int class. We talked briefly in our last lesson about how the integer class actually goes from negative 2 billion to positive 2 billion. What I can actually do is print out how big integers go. So I can say the largest integer is, and I can ask the integer class, what is your max value? Now, because this is a constant, I have to use these all capital letters. So constants are going to be completely capitalized. So I can ask it what the largest value there is in integers, and it says the largest integer is 2,147,483,647. A huge number. And I can similarly ask what the smallest integer is by doing the same thing. Say what's integer dot min value. And running that, it's going to tell me that the smallest value is negative 2,147,483,648. Notice that those numbers are not the same. And the reason is because integers are 32-bit objects. So if I take 2 to the 32nd power, I'm actually going to get 4 billion something. And if I cut that exactly in half will give me 2,147,483,648. So I should have that many negative numbers and that many positive numbers, except I've forgotten one very, very important number, and that's 0. And so what we do is we take the very last positive integer, let that be 0, and the ints only go up to 2 billion blah blah and 7. So I have a max integer and I have a minimum integer. Similarly, I have a maximum double and a minimum double. So let me go ahead and just copy some code here, but replace integer with double. So this is going to be double dot max value and double dot min value. If I run this, then I'm going to see the largest double is 1.7976 blah blah times 10 to the 308th power. That means I've got 1 followed by 308 zeros. So we're talking about decillions upon decillions upon decillions. We're talking about a huge number. And similarly, if I asked it what the smallest double is, it told me it was 4.9 times 10 to the negative 324. In other words, I'm talking about a minuscule number, 0.0000000, and 324 zeros later, then I finally get to the 449. So the double range is very, very, very wide. I can get very, very small with it, but I can't get 0. And that's something that's very interesting. 0 is not a 0 is too precise a number for the doubles class. 0 is only an integer. 0 is not going to be taken care of within the double class. So it's just something we need to be aware of. As a matter of fact, if we try to work with 0, we're going to get some very special values in here. Let me go ahead and do this. System.out.println. If I say double, not in quotes, double dot NaN, there is actually something in Java in the double class called not a number. And if I do a big enough calculation where I end up dividing by 0, or I end up dividing by infinity, something weird, something peculiar, Java will actually give me those results. It'll say your answer is NaN, not a number. So that is something that we need to be aware of. Java actually has 2 other constants. I could ask it to print out double dot positive positive infinity, and there actually is a positive infinity that Java deals with. If a number is too big, if the number goes outside of that maximum value, then Java just basically treats it as, oh, it's infinite. I can't deal with it. And if I do infinity plus 3, it's infinity. If I do infinity times 2, it's infinity. And similarly, there's another constant that is just like it, called negative infinity. That's basically infinity with a negative sign in front of it. So, the purpose of the integer and double classes, so far as we're ready for right now, is to deal with bringing numbers from the string class into an integer form or into a double form, and also to hold the boundaries of us. We're actually going to see more uses for the integer and doubles class later on in this course, but for now, this is a wonderful stopping point. So, once again, this is Mr. Potter. Thank you for watching. Have a great day.